Right, the function f has domain 4 infinity and is defined by f of x equals half root x minus 3. Find an expression for f to the minus 1 of x and write down the range and domain of f to the minus 1 of. So, part A, to get the inverse function, we need to write it as y equals, okay, we don't need f there, and we've got this, and then we're going to rearrange this to make it x equals. Now what I would do is reason here. We've got a half. Half just means divide by 2. So if we divide in by 2 here, we can take that over and times by 2 on the other side. Okay, so we get this. Now to get x equals, I've got to get rid of the square root. So I need to, take it over to the side, do the opposite. The opposite then is squaring. Now be aware, you need to square all of it, right? So when I take that square over, I need to make sure the square root over and becomes a square. I need to make sure I square all of that side, okay? So I get 4y squared equals x minus 3. So then 4y squared plus 3 will equal x. So your inverse function then is 4x squared plus 3, okay, in terms of x. That's your inverse function. So to get the domain and range, well, first of all, we focus on f of x. Its domain is 4 infinity, okay, and we're going to work out the range now of f. So if we put 4 into the function, 4 will become this, and if you work that out, you just get a half, and infinity in, infinity minus 3 is square rooted. It's still infinity, right? Okay, still goes towards infinity, so your range will be half, which is included, infinity then, okay, tending towards infinity. So there's your domain and range for f. So then for the f to the minus 1, they're just the other way around, aren't they? So the domain will be half infinity, and the range will be 4 infinity. Okay. Part B then, it says sketch the graph of f to the minus 1 of x. On the same diagram, sketch y equals f of x. So let's just look at what the function is to start with, f to the minus 1 of x here. Okay. Now looking at that, okay, we know what that looks like to me. It's a quadratic, smiley face, shifted up 3. Okay. We have to be careful where it's starting from. Okay. It's starting at a half, yeah, on the domain. So we don't want the whole graph. Okay. We have to focus on what our domain and range is, and making sure that we get the right part of the graph on there. If we don't do that, then we could end up drawing more of the graph that we want and we're losing marks. So there's your graph. Now we know quadratic looks like that. If there's a 4 under there, then it sort of increases quicker, so it'll become narrower there, okay? And then you're adding 3, so it shifts up 3. But really, you can just look at the domain and range here, okay, of f to the minus 1. So it's a half and 4. The lowest values there. When we're a half here, okay, then we're 4 up here. Right, so 4 is maybe about there. Okay, so x is half, y is 4. If you're not convinced, you've got your half there. That's the lowest value in the domain. Put half in there, and it'll come out as 4. Okay, so you know what it looks like. Obviously, it's going towards positive direction then from half to infinity in the x direction. Just going to go like that. Rises quite quickly. Okay, and it's important you label it f to the minus 1 of x. Now to get the inverse, because it says then, in the same diagram it says sketch the graph of y equals f of x. Remember, to get the inverse, we simply reflect in the line y equals x. Okay, and when you reflect, you can take the domain if you want, okay, of f to the x, f of x. Where was it here? 4 infinity, so we know we're starting at 4. And the range is half infinity, so 4. So we're starting at 4, and the y value is half. Okay, kind of like switches. So you've got that there, and you're going to draw your curve. And if you notice here, that curve is going away from the x-axis. Sorry, that curve is going away from the line y equals x. So it kind of starts here and it's going to do the same thing. It's going to go away from the line y equals x. It's going to kind of go like that. Okay, and label it f of x, and we've reflected it, and it's job done.